Least squares regression line. Y hat equals 5 minus 7x. What's the slope? The slope is the number in front of x, so it's -7. I read this wrong just a moment ago. It's when x increases by 1 unit, y hat decreases by 7 units. Because what this means is it means change in y over change in x. So if I look at the slope as a fraction, it'd be -7 divided by 1. So y changes -7 for every 1 change in x. So when x increases by 1, y decreases by 7. That's what -7. If I say decreases by -7, I'm really saying I'm adding 7. So when x increases by 1, y decreases by 7. Okay? Let's look at number 2. All right. So get the visualizer up here. So number 2, we're talking about interpolation and extrapolation. So when we're using y's to predict values of x found in the data, are we interpolating or extrapolating? So when we're doing it inside the data, or beyond the range of data, beyond the range of data, extrapolation. Good. Extrapolation, that is not a wise practice because extrapolating is dangerous because we do not know if that trend that happens within those values are going to continue for values outside of that x. So extrapolation is dangerous, not recommended. But anytime you're doing one beyond the observed x values, you're doing extrapolation. If you're plugging in a value between inside of the range of x's, that's interpolation. If two variables have a negative linear correlation, what's their slope going to be, positive or negative? If they're negative linear correlation, they're going to have a negative slope. So the r value, the correlation, and the slope are going to be the same. So if r is negative, then the slope's going to be negative. If r is positive, the slope's going to be positive. Okay. Example 4, an economist is studying the job market in Denver area neighborhoods. Let X represent the total number of jobs in a given neighborhood. Let Y represent the entry-level jobs in the same neighborhood. The same sample of 6 neighborhoods gave the following information. So a sample of 6 neighborhoods. I'm going to click use SALT, and SALT's going to help me here. Okay, so I'm going to go 2 windows. Now, to verify these, you could use this to verify if you want. Go to descriptive statistics, sum and sum of squares. Okay, like E of x means the sum of the x's, so that's 200. You don't have to worry about this though. 27, you could just go ahead, sum of squares. We don't have to verify that. Now draw a scatter diagram, same thing as a scatter plot. For this, I'm going to click regression. So click regression. For the x variable, I'll select total number of jobs in hundreds. Y variable, the number of entry-level jobs. And then I'm going to look at the scatter plot and see which one is appropriate here. So I've got a scatter plot. Notice my x's have the larger numbers on the x. The y's got my smaller numbers. It appears to be a positive correlation. So I'm looking for a positive correlation here. It might be this one right here. That one's negative. That one's positive, but that one's positive there. Negative. So we're down to, this one hasn't flip-flop. You see, it's got to be this one because notice that the 20 through 50 is on the x and the 1 through 8 is on the y. So that's got to be this one. Okay. Now, find x bar. X bar is the mean of the x. Okay. X bar is the mean of the x's. So what I'm going to do now is I'm going to go over to descriptive statistics. X bar is the mean of the x's. So it's that right there. So Control C, Control V. Y bar is the mean of the y's. So Control C. So that's the mean of the y's. Okay. Okay, now how do I make the regression equation? I'm going to go back to regression here. Okay, it does it for you, but you got to know how to read it. So we're going to have computer output, and you're going to know how to read it. So your computer output, the coefficient summary table, has the values you need. Okay, now the coefficient estimate of the intercept, I'm going to put that first. This is the y-intercept. We're going to put it a little backwards. I'm going to put Control C, copy that. I'll put that in here first. So that's the coefficient of the intercept. Okay. That is the y-intercept, but when they write this in this form, they put the y-intercept first. So I'm going to do it a little backwards than what you're used to. Now, this next one is the coefficient estimate of the x variable, the coefficient estimate of the x variable. So this is your slope. So I'm going to copy this, Control C. I'm going to put plus here because it's positive. So plus, then Control V. And then I'll put x attached to this because that's the coefficient of x. Okay, I'll move just a moment. Let me move this back. So on this one, you put the y-intercept first plus this coefficient here, which is the slope, it's the coefficient of the x. So plus the coefficient, so 0.2062 times x. Okay. All right, now we're going to go graph the least squares line. Now the least squares line, keep in mind it's a positive relationship, so it should be one of these two positive ones, and it will have the mean point on that. What does that mean? It'll have this coordinate. It'll have the coordinate 33.3333 and 4.5 on there. So I'm looking for the one that has 33.333 and 4.5, so like this one, that point there, and it's a positive one. So I'm looking for that one right there. So mine's 33.333 and 4.5, and it's positive, okay? All right. Now, find the r squared. The r squared is the coefficient of determination. They give us that. So r squared is right there. So Control C, Control V. Now, that's the coefficient of determination. Now, what that does is that tells you the percentage of variation of y that can be explained by the variation in x in the least squares regression line. So what you're going to do for this next spot is we're going to express this as a percentage. So I move the decimal over to the right 2 spots. I get 83.33%. So 83, so you convert this to a percent. So move it over right 2 spots. Now, what percent's unexplained? Well, there's 100% total. So to find how much is unexplained, I'm going to do 100 minus 83.33. I get 16.67. All right, so now for the last one, for a neighborhood with x equals 41, how many hundreds are predicted to be, how many hundreds are predicted to be entry-level jobs? So what you're going to do is you're going to plug in this 41 into this equation you made up here. So I'm going to plug in 41 for x into this equation. So I'm going to type that equation, negative 2.3719 plus 0.2062. I believe I had times 41. You put in 41 for x, okay? So I just type that equation and type in 41 for x. And I round to the nearest 2 decimal places, so 6.08. All right. All right, let's look at number 5. So at number 5, you're the foreman of Bar S Cattle Ranch in Colorado. A neighboring ranch has calves for sale. You're going to buy some calves from the Bar S herd. How much should a healthy calf weigh? Let X be the age of the calf and Y be the weight. So first thing I'm going to do is I'm going to click Use Salt. I'm going to move this over here. Okay, and I'm going to get out of my previous salt window. I could verify if I want. I don't need to, but I can click sum and sum of squares, and it will show me 93, 618, 2,321, 82,000. So I could do that. I don't need to worry about that. Let's draw a scatter plot. So scatter plot, I'm going to go over to regression. My x variable is my x, age in weeks. My y variable is y, weight in kilograms. And I'm going to look at the association here. It's positive. And The X's are the smaller ones, the Y's are the larger numbers. So I'm looking for a positive. X are the smaller numbers, Y's are the larger numbers. This is looking good right here. X are the smaller, Y are the larger. It's positive. I think the other one's going to have them flip-flop. So you don't want that one. You want this one right here. Okay, let's go to the main point, X bar, Y bar. So to find this, I go back to descriptive statistics. X bar is the mean of the X's. So I'm going to control this, copy this. Y bar is the mean of the Y's. Control C, Control V. So X bar is the mean of the X's. Y bar is the mean of the Y's. Now we're going to go over to regression to go get that equation. So I'm going to go back over to regression. I'm going to look down here. And so I've got these two coefficients down here. I'm going to start with the coefficient of the intercept. So I'm going to copy this. And I'll put plus. And I'm going to do, this is the coefficient of the X. So I'm going to do this. Watch out here. Control C. Control V times X. So this is backwards from what you're used to in Algebra 1, Algebra 2. They start, which it doesn't matter. You could do it flip-flopped if you want. They wouldn't be wrong. But I start with the Y-intercept, which is that, plus this, which is the coefficient of the X, which is the slope. So 4.6163 times X. Now, I'm looking for the graph that has 15.5 and 103 on it. 15.5, 103, and I want like this looks like it's going to be it. And I want a positive correlation because it's going up. So 15.5, 103 right here. So that's what I want. Okay, now what I'm going to do is I'm going to go down here to R squared, the coefficient of determination. R squared is 0.9931. Okay. That means that 99.31 of the variability of variation in Y and the weight of a calf can be explained by the calf's age. What percent's unexplained? For this, I'm going to do 100 minus 99.31, 0.69%. Okay, now for part E, I'm going to use my equation to make a prediction. The calves you want to buy are 23 weeks old. So 23 weeks old, that's an X. What does it predict about the weight? So I'm going to go back up here to my equation. I'm going to plug in 23 for X. So 31.448 plus 4.6163 times 23. And they want me to round to two spots. So 137.62. All right. All right. Last one here, number 6. So the heavier cars, you really use more gasoline. Suppose the car shows it at random. Let X be the weight of the car and Y be the miles per gallon. So we're going to use salt here. You X out of this one. I could verify, once again, by descriptive statistics. I'm going to go straight to regression here. So regression. And my X is the weight of the car. Y is miles per gallon. Now notice it's a negative correlation this time. got a negative correlation. We got some larger numbers on the X, smaller on the Y, so negative. You see how this one looks probably right there. Wait, actually, be careful. Yeah, you see how this last one's backwards. So you've got kind of the larger numbers on the X, not quite as large on the Y. Okay. Now, these statistics you can get from a variety of ways. Verify the sums and the value. You could verify using descriptive statistics, or you could just copy these down. So you could literally just go Control C, sum of the X's, and come down here and just paste it in there. Sum of the Y's. Control C. Control V. Yeah. All I'm doing is copying these answers. They gave you the answers. And as I said, you could go look them up if you don't believe me, but they are in your table. Control C. So on the table, now your table does not include they're in the descriptive statistics if you want to check here. The problem is it does not do the product of the sum of the product, but you have to actually add it in there. So you have to go back here to sum and sum of squares, add those in there. That's the sum of the X, that's the sum of the Y. I'm gonna take this comma out. And then the problem is it does not include the sum of the product of the two, this EXY, but you can get that. That just means if I multiplied all the X's and Y's together and then add them up, the products. EXY is up here though. And R is up here as well. So these are tools you could use to calculate the line of best fit by hand or by more the theoretical way. R is the correlation coefficient. They gave that to us as well. Okay. Now, find the X bar, Y bar. That's just the mean of the X's, mean of the Y's. So the mean of the X's is right there. Mean of the Y's is right here. Control C, Control V. And then my best fit equation, I'll go back to regression. My first blank is the y-intercept. So I'm going to use the coefficients estimate for the intercept. So I'm going to move this out of the way. Control C. Control V. And then the coefficient of x is this value down here. So I'm going to need to get this out of the way so I could move this. Control C. Control V. This time I'm looking for a negative correlation, and I want 37, 20.375 to be on there. So it's not going to be that one because that's the backwards. So like you see 37. So I want this one right here because that's 37 and 20.375, I believe. Yes. R squared is 0.951 for me, so I'll control paste. Move the decimal over 2 spots. 95.1% is explained. What is unexplained? 100 minus 95.1, 4.9. Now, suppose your car weighs 4,500 pounds. What is the least squares line forecast for Y? So what's the Y forecast given that X? I've got to find my equation. So X is 45. So I'm going to plug it in that equation. 41.5247 plus negative 0.5716 times 45. 15.80. I believe it's 2 spots, so 15.80. And that's your answer.